Hello and welcome to video number 11, Linux Package Installation and System Backups. This is part of Fast Track CBT Video, Linux Networking and Administration. This is our table of contents for video number 11. First off, we'll talk about Linux package installation, then system backups and restores, how to access and record unrecordable media, and repairing packages. So we'll start off with Linux package installation. Now Linux Plus Objective 1.9 says that you should be able to manage packages after installing the operating system, and it says, for example, installing, uninstalling, and updating packages. And specifically it mentions RPMs, and we're also going to talk about yum and yumx. Now Linux uses the concept of packages to install application updates, new applications, or new services. The three most common forms of Linux packages are RPM, Debian, and tarballs. RPM is the most popular by far. Tarballs are the most basic and they're widely supported, but they also have the least functionality. Now RPM was designed by Red Hat as Red Hat Package Manager. That's where RPM comes from. It's now available on other Linux distributions, and it was released under the General Public License, or the GPL, so the source is freely available. Now RPM supports various hardware platforms, so you can run RPM on all sorts of different hardware, IBM RS6000 servers, PowerPC servers, Sun servers, of course all sorts of Linux servers. So RPM is very popular. There are lots of RPM depositories on the internet, such as this one, rpmfind.net. If I click here, let's go take a look at it. This is the RPM repository. So if you scroll down, you can search here by typing in keywords. You can index by name, index by category, distribution. Here's RPMs for different platforms, Alpha, Spark, PowerPC, all sorts of good stuff. And this is just one of the many RPM repositories out on the internet. Now the normal method for identifying RPM packages is to use this scheme. Right here, package name -a.b.c-x.architecture.rpm to tell you it's an RPM package. The a.b.c is the package number, and the x is the build number. So this could be like version 1.2.3 -build 4. And the architecture would be like i386, or it could be Alpha or PowerPC. But those are the types of files that you would be downloading. So this would be a single file for whatever application or package you're trying to install. So if you want to install the latest version of Apache web server, it might be called Apache-4.5.2-6.i386.rpm, and you would download that single file from the internet, say like from either this RPM find website or one of the other ones, or maybe from the Apache web page. So you could download that single package. Think of it almost like a setup.exe in Windows, where they've packaged it all in this executable file. You run it and it just installs everything, and it knows what it requires, and it looks for all the different things on your system to make sure it's compatible. So that's what you compare this to. Now RPM supports dependencies, so it knows what you're lacking and it will tell you. Unfortunately, it won't go and get it and install it for you. At least the command line RPM won't. So you kind of have to go get those packages yourself. The RPM program has a ton of options. If you just type RPM and press enter, you'll get a whole page of just different options for RPM. So it can be a little daunting at first. I would suggest reading the man page on RPM just to learn more about it. But here are some common options here. -I is used to install a package. -U is used to upgrade a package. -F is used to freshen a package. Minus Q queries the package install, tells you what's installed and what version and everything. Minus capital V verifies a package to make sure it's there. And minus E uninstalls a package. Now, internally, RPM uses the CPIO program, which we're going to discuss in the next slide, as its internal file archiver. So CPIO is kind of like a zip program almost. It doesn't do compression, but it takes a bunch of files and puts them all into one file. So inside this RPM package is a CPIO package where, and that's where it gets all the files that it's going to install. Now, Fedora offers their GUI package management program, and it's called Add Remove Programs up on the command bar, and it's called system-config-packages at the command line. So you can run it from the command line, or you can go up to the toolbar on the top. This program is like the Windows Add Remove Programs. So it knows what you already have on both the Fedora CDs, and it can install those programs for you. So just like when we did the system installation, we could select what packages we wanted to install and not install. It's the same thing. Now, it won't go out to the internet and find stuff for you. It will just tell you what it has on CD already that came with Fedora, and you can choose to install it or not install it. So Fedora Core 5 also offers a scaled-down version of YumX. And let me tell you what Yum and YumX are first. Yum is a package updating program, and it's also a new package installation program. Yum stands for Yellow Dog Updater Modified. Now it can go out to the web and tell you what updates are available for the various packages you have and update them for you. It can also find new packages that you don't have. So if you don't have a web server, it can tell you, hey, there's a web server out here available on the internet, and you can say, okay, I want to install it. Now, it's not quite that easy with the command line version. The command line version is called Yum. That's the command line. The graphical version is called the Yum Extender, or YumX. It's a GUI front end for the Yum program. So this makes it a lot easier to use, the YumX program. Now, like I said before, Fedora Core 5, this is new in Fedora Core operating system, has a scaled down version of YumX. So what the scaled down version of YumX does is it'll go out and it'll just refresh packages that you already have. So it says, hey, there's a new version of the web server out here. You want to update it. There's a new version of OpenOffice out here. Do you want to update it? So that's what the version inside Fedora Core 5 does. Now, if you download the full version from the internet, YumX, you can get new packages that you don't already have using it. So it's a very cool tool. I highly recommend you check it out. I will show you the Fedora Core scaled down version of YumX. We'll see that in just a second. For now, let's go out and let's install 3 CD burning packages off of the Fedora Core distribution, and we're going to use the Fedora Core Add Remove Programs application, the System Config Packages program, to do that. And then after that, I'll show you what the scaled down version of YumX looks like that comes with Fedora Core 5. Alright, so we're over here on our Linux server, and what I did is I went in and I started the package manager. I went up here to Applications, and I went to Add Remove Software. So this is how you add and remove software that comes on the Fedora Core CDs. Now there's a lot of software that comes on the Fedora Core CDs. A lot more than you would get with like Windows XP. Windows XP doesn't have a lot of choices. Even Windows Server doesn't have a lot of choices compared to what you get on the Fedora Core CDs. There's hundreds and hundreds of packages. So I clicked on that, and it takes a little while to search through the database. So I've gone ahead and started it up already for us here. And this interface has changed dramatically since Fedora Core 4. It's much improved. It has a search, browse, list function over here. So what I can do is I can scroll through these different areas here. And for instance, in the desktop environment, there's 3 different packages I can install over here. And notice if I click on them, sometimes it'll have this down here and a button that says optional packages. So like I clicked on the GNOME desktop environment and it says 35 out of 54 optional packages are selected. This is something important to know about, because just because it's checkmarked right there doesn't mean the whole thing's installed. Only 35 of the 54 optional packages were installed. So to get more packages, you click here, and these are all related to this GNOME desktop that we selected up there. So for instance, the desktop recorder is not installed. The simple menu editor for GNOME is not installed. So you see all these little check marks here on the left of things that aren't installed. And a lot of times there's a lot of cool stuff in here that isn't installed at all. I don't know if that's the case for GNOME. Let's go look at some other applications. So if you click on applications here, for instance, there's no authoring and publishing tools installed at all. So if I check that, it only installs 9 out of 13 optional packages. So to actually get all 13 packages that are there, you have to click on this and then add the other packages manually. So I don't want any authoring and publishing. But if I scroll through here, there's only 1 of the 8 editors installed. Office and productivity, only 9 of the 36 packages are installed. Let's see, this is DIA. This is like Microsoft Visio right here. You can install this. That's a cool tool. Abby Word is like Writer in OpenOffice or like Microsoft Word. GNOME Time tracks and reports time spent. GNU Cache or GNU Cache is an application to keep track of your finances. So this is like QuickBooks. It's one of the few financial tracking applications for Linux. Here's a recipe manager, personal finances, PDF previewer, K-Office, personal information manager, presentation software, note manager, all sorts of good stuff. OpenOffice database. All sorts of good office productivity tools. So anyway, you scroll through here, you get the idea. Different servers. Here's the FTP server. You install that. So if I check that, I go down here to optional packages. I have to select actually which FTP servers I want installed. But a lot of good things to install. So let's go to applications. And what we're here to do is to install the 3 different CD recording packages that are available. So let's go through here and find them. Notice that CD Record is a command line CD/DVD recording program. It's already installed. It was installed by default. So I want to install GNOME Baker, CD/DVD burner. I want to install K3B, and I want to install XCD Roast. So if I say close and apply, it says you have selected the following software for installation. So here's the packages right here. See this GNOME Baker-0.5.1-4. So this is the version, this is the build, the -4, and it runs on Fedora Core 5. It doesn't tell you, the architecture and things like that. But that's the package name. So if I click continue, now the cool thing about this application is it tells you what dependencies are needed, and it goes out there and it gets them for you. So basically there's other libraries and stuff that are required by these applications, and it tells you what they are, and it says, hey, I'm going to install them unless you stop me. So all you have to do is click continue. Many times if you're doing this manually from the command line using RPM, you have to go find these packages, download them from the internet, and install them. So I've tried to install FTP server before and had to go out and download 3 other packages just to make it work. So this is a really handy tool for you. So if I click continue there, it says downloading packages. It's not really downloading packages from the internet. It's downloading them off of the Fedora Core CDs. So while it's doing that, let's go over and I want to show you RPM. So if I type RPM and I pipe that to more, so as you can see, there's a ton of options here for RPM. I mean, it looks like alphabet soup up here with all the different configuration options. And then down here is like another full page of other configuration options. It's amazing everything you can do with RPM. So if I type man and pipe that man RPM, pipe that to more, you can see here the query option is what you use to take a look at what packages are out there. V is for verify, F is for freshen, I is for install, U is for upgrade. I wanted to show you the examples down here at the bottom. You can actually use RPM to download packages directly from the internet using FTP or HTTP. So that's pretty cool to be able to download them directly from the internet. RPM, of course, has a large database of packages that are installed, and that's why when you start the add remove packages program, it sits there for a long time examining that database. Same thing when you start Yum, it sits there for a long time examining that database. So that's RPM. Let's go over here and check on our package downloading. Looks like it's still working on it. Let me show you Yum. Yum again is the command line tool to update packages. So if I press enter here on Yum, this gives me the help options. So we have update, install, info, remove, list, clean, check update, all sorts of options here. Let me do man on Yum. The yellow dog updater modified, an interactive automated update program which can be used for maintaining systems using RPM. So you have to be using RPM to use Yum. So you can do update, check update, install. So there's these Yum repositories out on the internet that Yum has to go out to and check and see what the latest updates are for the packages that you have, and that way it can tell you what's available, and then you can choose what it is that you want, to have updated. There's a file, important file for Yum called the etc yum.conf file. This is how it knows what repositories out on the internet to go search for updates for your system. So over time you'll gain familiarity with the names of the packages. Initially it can be a little daunting because there's so many packages and so many different names for those packages. You might have hundreds of packages installed on your system. So knowing what all those packages are and what they do can take some time and some experience. Of course, you can go out to the internet, to Google and just type in the name of the package and easily get a description. And then tools like the add remove packages and Yum will also give you, a basic description of what the package is and what it does. You can see here there's a wiki on Yum, and I see our updating software is flashing back here. Let's go over here. Nope, still updating software. Should be almost done here in just a second. Looks like it's thinking about it. So that's Yum and Yum.conf. So Yum again is the command line tool. YumX, or the Yum extender, is the GUI tool. Now, Fedora Linux really doesn't have the yum-x installed. But what it does have is if you go up here to Applications, System Tools, it has this thing, Software Updater, which is kind of a scaled down version of yum-x. It can only update the packages you have. It can't install new packages, just do updates. And it looks like, to me, it only goes to one repository, whereas yum-x you can configure to go to a lot of different repositories. So if I close this out, still updating software. We can't start we can't start this updating tool here until the package manager is done with its updates. So, and that's because they both look at the same database. They both go and look at the same RPM database, because yum-x is examining the RPM database to see what RPMs we have now. Then it goes out to the internet, it sees what the latest versions are of those RPMs, and then it compares them, and if there's new ones, it tells you, hey, these are the new ones you can choose. Do you want to do these updates? So with that, let's go back to our slides, and we'll come back later when the updating software is completed. So you saw how to install the 3 different CD burning packages off the distribution. We use the Add Remove Packages program that's built into Fedora Core to install GNOME Baker, K3B, and XCD-Roast. These are the 3 CD burning packages that we're going to use a couple slides from now to learn how to burn CDs under Fedora. So with that, let's go on to our next slide, which is System Backups and Restores. On the topic of system backups and restores, first let me mention Linux Plus Objective 2.8. It says that you should be able to perform and verify backups and restores, and it specifically mentions tar and CPIO, 2 commands that we're going to talk about in this section. So first off, I want to point out that Linux offers a wide variety of backup programs. There's a number of backup programs that come already inside Linux Fedora, and then you can go out to the internet and download many more. Now, all these programs provide very basic functionality needed to back up and restore your system. Some of them that you go out on the internet and download, of course, provide much more advanced functionality. But all the programs that come with Linux Fedora are pretty basic programs, but they do the job. Now, let's start off with tar. Tar is the tape archiver. It's a command line tool used to archive files to a single file. So on Windows, you might think of this as like a zip file. Except tar by default doesn't really provide compression. It can if you tell it to, but by default it doesn't. It just takes all these files that you tell it to put in an archive and puts them in a single file called an archive, a tar archive. Now that file could be a disk file. You could send it directly to tape, or you could send it to some other media format like CD. Tar files end in a .tar extension, and when you create one, you should create it with a .tar extension. Now, when combined with gzip or bzip2 for compression, the file may have a .tar.gz or a .tar.bz2 extension. And that can be further combined into a .tgz or a .tbz. So when you go to download some application from the internet, it might have a .tgz extension, and you need to know that that's a tar file that's been gzipped. That way you know how to uncompress it. Now, tar is frequently used to distribute software. These programs tarred into files are called tarballs. So this is similar to a RPM archive. A tarball, though, is much more basic in functionality, and it's basically a tar archive of this application you're going to install. And it really doesn't provide any other intelligence like RPM does, in terms of what are the dependencies do you have, and updates and refreshes and things like that. It's just a big compressed archive, or potentially uncompressed archive of files. Now, commands for tar are C to create an archive, A to append to an archive, T to list out the files in an archive, I call this table of contents, and extract to extract the files from an archive. So C to put the files in and X to take them out. So a sample tar command would look like this: tar xvf/backup file. So here you're saying I want to extract whatever files are contained in this file called backup.file, and I want a verbose output. I want to see everything. And the F tells it that you're pointing to a file. That's the file right here. So normally this file might be called backup.file.tar, right? Because it's a tar file. Now another common backup archiver program is CPIO. This stands for copy in and out. CPIO, copy in and out. Now the CPIO -O option is used to copy out. -I is used to copy in. This can be a little confusing. So out means I want to go out of my system, out of my hard drive to a file or to a tape device. -I means I want to copy in from a tape device to my system. Now the -F option specifies a file or a device, as everything in Linux is a file. So this is where you specify the name of the CPIO file on your disk or the name of the tape drive, /dev/mt0. Now to send the output to or read from a file, you're using the -F. So when you use the command, this is what it looks like. CPIO -I would take input from a file, this file here, that's what the -F is, and bring it into your hard drive. Now the MT command is used to control a tape drive. I call this MT mag tape. The control includes moving the tape forward and back, fast forward, rewinding, and getting status on the tape. So you got a tape in the drive. You need to know, is it write protected? What's the status on that tape? Does the system recognize it as a good tape? I need to fast forward it to the third file on the tape so I can pull off a tar archive. Well, that's what you do with the MT command. You fast forward it, you rewind it, you eject the tape. Now, special tape devices can be used for no rewind and other purposes. So, say you want to send a CPIO output to a file, you could say that file is /dev/rmt for, say, removable mag tape 0, and then there might be a dot no rewind on the end. So that dot no rewind tells it I want to remove the files, but at the end of that file on the tape, don't rewind it all the way back to the start. And people usually do that because they're about to remove a second file on the tape. So the tapes will have multiple files on them, and you can use MT to fast forward and rewind to the different file numbers. So you don't want to rewind the tape all the way to the beginning when you're done removing the first file, because you want to go ahead and remove the second file after that with a separate CPIO command. Now, I caution you to make sure that you test your backups on a periodic basis to make sure they can be restored. There's no worse feeling than doing backups consistently every day for a year, and then your hard drive goes out and you try to restore the backup and it doesn't work. So make sure you test your backups. Testing them can be just as important as backing them up in the first place. Now, other backup programs are KDAR, and here's the website for that, and Amanda. These are both GUI backup programs. With Amanda, you get full client and server backups, so you get network backups with Amanda. Network backups mean you have a backup server with a tape drive, and then say you have 5 other Linux clients out there. You can have those clients back up their files to the server over the network, and then that server would put those files on the mag tape. So all these programs are free and available for download on the internet, and there's a complete list of backup programs available for Linux here at this website. There are a ton of backup programs. I mean, this website has pages and pages of them. So KDAR and Amanda are just examples of backup programs that are available. So with that, let's back up some files using tar and CPIO. Alright, so I'm over here on my Linux server. I'm at a command prompt logged in as root. I'm in my home directory, and I'm going to create a backup of all the files in my home directory using CPIO. So if I do an ls-l, here's all the files in my home directory. So first off, CPIO works by you sending it a list of files. So I could do ls and I could send it a list of files using ls, or I could use find minus print, and if I press enter there, you can see that's the list of files it's going to send CPIO. So if I clear the screen and I do find minus print again, I pipe that to CPIO, and I'm going to do an output. So I want to go from my hard drive out to a file or to a tape, and I have to put the F for the file to specify the file. So I'm going to call this home-dir backup.cpio. So that's the name of the file it's going to send all these files to and put them in that archive file. So if I press enter, it says it did 19,319 blocks. If I do an ls-l, here's my backup file right here. So that's what, 9.8 megs. So almost 10 megs to my home directory backup. If I do a CPIO minus TF and I say home dir backup.cpio, this will give me a table of contents of all the files that are in there. There we go. That's all the files in the archive. Now if I make a directory and call it home copy, and I cd into home copy, and I use CPIO minus I for input to bring files back in from that archive, minus F, and it's in the previous directory, and it's called home dir.cpio. Whoop, what was the name of it? Home dir backup.cpio. Alright, we're in the home-copy directory, and it's called, see how I use that up arrow right there? That's pretty handy. That saves my day. So it's called home-dir-backup.cpio. So I'm going to take input from that file, and I'm going to restore everything in that archive and put it in this home-copy directory right here, which is a subdirectory of my home directory. So if I press enter, voila, it's done. I'll do ls-l, and there's all the same files that were in my home directory, but now they're in this home-copy directory. So I archived them, and then I unarchived them into a subdirectory. So that's how CPIO works. It's pretty simple. Really, copy in, copy out. So now let's try tar. So to use tar, I type tar, and I'm going to type C to create an archive, V for verbose, and F for a file. I want to send it to a file. It's lowercase in tar. And I'm going to do home dir backup.tar. It's the name of my file. Then out here I have to specify a list of files. I'm just going to do asterisk for all files. So it lists all the files while it's doing it, and it should have created a tar archive. Let's see. If I do ls-l, here's my home dir backup.tar. And notice it's double the size of the home dir backup.cpio. That's because there was the home directory, then we created a CPIO archive of it, then we unzipped that into home-copy. So we have two copies here of our home directory, and it's in a tar file. So let's see, what is that? 21 megs. 21 megs. So if I make a new directory and I call it home-copy-tar, and I do tar xvf, then the name of the tar archive here, home-dir-backup.tar. Whoop, it didn't like that. What'd I do wrong? Tar xvf for extract Error is not recoverable. Cannot open no such file or directory. Oh, okay, I'm not in the right directory. Let's do a pwd. Okay, it's not. Notice my syntax right here. Part of finding errors in Linux is just looking at your syntax and seeing where you made a mistake. So I said go back to the previous directory, which would have been the root directory, the slash directory, right? Because I'm in /root. So if I go back to the previous directory, which is slash, and find this archive file, it's not there, of course, because I didn't cd into the home-copy-tar. So let's do that. Cd home-copy-tar. Now I can just use my up arrow. Now the previous directory is my home directory where the home-dir-backup.tar file is stored. So we have our extract command there. Now let's extract. There we go. If I do an ls-l, there's my home directory, and it's now located in home-copy-tar. So I have my original home directory in /root. I have my CPIO copy of home in home-copy, and I have my tar copy of home in home-copy-tar. So that's basically how CPIO and tar work. We did this all to disk files, but of course you would also do it to a tape with a like /dev/rmt0 for a removable mag tape or any other sort of tape. They might have different names, but you're still going off to a device directly like a tape drive. So with that, we can go back to our slides, and we can move on to the next topic, and that topic is accessing recordable media. So this is based on Linux Plus Objective 2.9, which says access and write data to recordable media, for example CD-RW, hard drive, and NVRAM. So Fedora Core 5 has a CD auto mounter. That way you don't have to manually mount your CDs. So when you put in a CD, it automatically mounts the file system. On Windows, that's something we're used to having already, right? You put in a CD and you go to your D drive or whatever your CD drive is, and voila, there's the CD right there. You can look at the contents, run the programs, whatever. Well, in Linux, that's not the case by default. You put in a CD, and in the past, it wouldn't mount that CD. You had to go and mount it, just like you mount a file system. Well, the auto mounter is a daemon that runs, and it checks for new CDs. When it finds one, it mounts it for you. So that's a nice convenience. You can also use the mount command to see what device your CD is on once it's mounted. It should be on the mount point /media. On my Linux system, my CD drive is called dev-hda, but that's because I have no other HTA disk, only SCSI drives. So my first HTA drive on my system is HDA. Now, traditionally, recording to a CD from Linux was a two-step process. You would first use the mk isofs, or make an ISO file system command, to create a disk image of the files that you want to burn. Then you would use the cd record command to burn those files to a CD. This would require you to know some exact command syntax. Now, while these commands are still available for anyone to use, it's easier to use the GUI tools to do this. In our case, we're going to use Drive E, and with that, we'll check out 3 different CD recording programs that are included on the Fedora Core 5 distribution. We installed these programs earlier. They are GnomeBaker, K3B, and XCD Roast. Alright, so let's go check out these programs. Okay, I'm over here on my Linux server, and what I did is I added a second CD-ROM drive. And I only did this so that you could see the difference between a blank recordable CD and a CD with data already on it. So because this is a virtual machine, I can simply go in and just with a few clicks add a new CD-ROM drive. So this is the equivalent of taking a physical CD-ROM drive, putting a second one in a PC or a server. Now, you don't need to do this. This is really just for demonstration purposes, so you can see what it's like to have two different CD drives. So if you look here, I have one CD here that says FC5i3d6. This is the Fedora Core 5 disk 1 of 1. So this was auto-mounted. I didn't have to do anything to get that there other than put in the CD. So if you scroll through here, you can see all the different folders and files that are on that CD. So that's one CD. And if we go to go to a command prompt, a terminal window, if we type mount, you can see here, here's the CD that's mounted. The name of the CD drive is dev HDA, and it's mounted on media disk. So it auto-mounted that. The type of file system is ISO 9660, and it's a read-only. See that RO. Up here, this is the auto-mounter that automatically mounted the recordable CD. You can see its type is RW, and it was mounted on /net. So two different CDs. The other CD, the recordable CD, is right here, blank CDR disk. So if I double click on that, this gives me a program that's built into Fedora here where you can create CDs. So I can create a folder, I can copy and paste things in here and set up this CD to be burned, and then I can click write to disk and write to disk. So that's one easy way to write to a blank CD. Another way is to use the command line programs that we talked about through the terminal window. CD record and make ISO FS. Actually, you would have to make ISO FS first, put files in it, and then use CD record to record that onto a CD. Now we installed 3 new tools, graphical tools, to help us burn CDs. So the first 2 are installed here in Sound and Video. GNOME Baker is one and K3B is the other. The third one for some reason was installed over here in System Tools, and it's called XCD Roast. It actually says X Roast here in CD Writer, but it's called XCD Roast if you go to the command line. So let's start off by running each one of these and just take a look at them. So GNOME Baker, I thought was a very nice looking program. It does DVDs, recordable DVDs and rewritable DVDs. So with this, I can just go through here and I can add, folders and directories and files, and tell it what I want on my CD. I can drag and drop down here. You can see so much of the CD was used. It defaulted to a 200 megabyte CD. I'm going to tell it this is actually a 700 megabyte CD. And I could say create data disk, and it would create that CD for me. It can copy data CDs, copy audio CDs, burn DVD images, burn ISO images. So it looks like a really nice program. We'll quit out. The other one I want to show you is K3B. Now it too looks like a really nice program. You can do a new audio CD project, new data CD project. These programs are a lot like Nero in the Windows world if you've used that before. One of the more popular Windows CD recording programs. So this is pretty similar here. This is pretty similar here, and as you can see, you can do a new data CD project. You can drag and drop files down here. Then you can say, I want to burn this. So pretty similar. Let's close that out. That was K3B. We're going to discard our project. And then the other one that we installed is XCD Writer. If I click on that, it tells us we need at least 1024 by 768 to run XCD Roast. So what I'm going to have to do is I'm going to have to run it from the command line, XCD Roast. There's a man page for it, and that's how I read about this -N option that allows you to get around the requirement for 1024 by 768. So if I run that, notice I didn't put an ampersand here. I didn't run it in the background, so it's running in the foreground in my window. So I can't do anything else with this window until I'm done with CD Roast. If I minimize that, let's see, we can do create CD DVD, and here we can, read tracks, verify tracks, play audio tracks, write tracks, delete tracks. So it's sort of a front-end interface for CD Record, the command line program. But I wasn't as impressed with XCD Roast, and maybe that's because it's a version 0.98 alpha release that came on the Fedora CD. Hopefully there's a better version that has more functionality and is a little bit easier to use. So let me close out of that. Actually, we can go back here to our window and we can just close the window, and that'll close everything. So we just finished learning about how you can use the mount command to see what CD is mounted and where it's mounted, how they're usually mounted in the media directory, how traditionally with the command line interface you use the make isofs command to create a disk image, and then you burn that disk image to a CD with CD record. Then we learned about our 3 different CD recording programs that have graphical interfaces: GNOME Baker, K3B, and XCD Roast. How these are included on the Fedora Core 5 CD distribution. Of course, there's many others you can download from the internet. So on the topic of repairing packages, Linux Plus Objective 2.13 says you should be able to repair packages and scripts, and they say, for example, resolve dependencies, repair, install, and update applications. Objective 3.14 says you should be able to configure the system and perform basic makefile changes to support compiling applications and drivers. So let's talk a little bit about this. First off, in Linux, one package may be dependent on a number of other packages being installed. So unlike in Windows, when you can download a setup.exe program, you run it and it just installs everything, that's not always the case in Linux. Many times you'll download a program and you'll try to install it and it'll say it requires 3 other programs to actually be installed. Sometimes you'll download those programs from the internet, try to install them, and one of them might say it requires 2 other packages to be installed. So this can be a little frustrating sometimes. And these packages that say they have to be installed before another one can be are called dependencies. Dependencies are usually libraries or support programs required by the original program. For example, all KDE programs require the Qt widget set to be installed. Now, many times you have the dependencies, but they're the wrong version. Other times the package has the wrong name or conflicts with another package. When trying to install a package, it will tell you if it's missing dependencies. Many times, the only fix is to go out and download and install the programs that it requires. However, there are some possible fixes you might be able to use. First off is you upgrade the original package or replace it. Perhaps a newer version or a different version doesn't have those dependencies. Next, you rebuild the package with the rpm-rebuild command. Or you force the installation using the no deps or no dependencies or force options for RPM. Although once you do that, the package may or may not work because it doesn't have the dependencies that it said it required in the first place. Or you could find another version of the package, newer or older, see if you can use it as a workaround. Or get another similar package. Many times in Linux there's so many different applications that do the same thing, and they won't all have the same dependencies. Now, a common dependency for compiling source code is a compiler. For example, the GNU Compiler Collection, or GCC, may be required. This is the C compiler, the standard C compiler in Linux. If you want to compile anything in Linux, most likely you're going to need GCC. Now, other applications may require an interpreter like Perl or Python. An interpreter just means it's not the source code isn't compiled ahead of time. It's compiled at the time that the programs run. Now, when trying to compile a package, always check for files that look like this: capital README, install, or configure. Read these files and learn what it takes to make this program work on your system. If you don't, you're just shooting in the dark. You could try to get a program to work, but the real knowledge on how to make that thing work is located in one of these README files that comes with the program. Now, usually to compile a program, you'll have to use the make command. After a package is compiled, you'll need to install it. Usually you can do this with the install script or the make install script. Now, when downloading source code to be compiled, periodically you may have to edit the make file to customize it for your system. The makefile is really just a script. For example, you need to edit the makefile to change the path of your GCC compiler because the makefile has it hard-coded to the wrong path. So you use VI. We talked about script editing. We talked about editors like VI. You could even use the graphical program gedit, edit that makefile, go in there and make it right. Make it right for your system, and then it'll work. Unfortunately, this is sort of a common practice for a Unix administrator to get something to work sometimes, as he might have to, tweak and band-aid and, just get things working however, any way he can to get the programs that he needs to do his job. So it's an important skill that I want to point out. So let's move on to our next slide, which is the conclusion for this video, video number 11. So in conclusion, in this video we talked about Linux package management, and much of that is done with RPM, the Red Hat Package Manager. Red Hat Package Manager has tons of options, and because of that many people end up using the GUI programs to do this instead. So like in Fedora, it comes with the Add Remove Packages program. Very handy tool for packages that are already in the Fedora CD. Now if you download something new from the internet, you can also use Yum, which is the command line tool, or YumX. Fedora Linux comes with a scaled down version of YumX, which will go out to the internet in a graphical interface and get you updates for the programs you have installed on your system. However, it won't add new programs, whereas the full version of YumX will. If you go out and download YumX, it will. We learned about system backups and restores. We used the CPIO and the tar program, and there's a ton of other programs out there available. We talked about accessing recordable media, and we looked at some different programs that we installed earlier in the video, and we found out just how those work. We looked at GNOME Baker, we looked at K3B, and we looked at XCD Roast, as well as the command line tools make ISO-FS and CD record. Finally, we learned about repairing packages, compiling packages, make files, and how that's an important skill that many system administrators use periodically in their job duties, administering a system, updating programs, and compiling programs. So with that, we've come to the video end. This has been video number 11. Thank you very much.